Welcome to the Turf Zone podcast. This episode features the article Influence of Management on the Microbiome of Turfgrass Systems by Benjamin Snell, graduate student at North Carolina State University. Home lawns, golf courses, and athletic fields account for the majority of the turf industry. A considerable amount of research has been conducted within these areas of the industry with a primary focus on management strategies. Improving management strategies is crucial for turf managers to produce high-quality turf that is economically and environmentally sustainable. One area within the turfgrass industry where knowledge is limited is the impact of these management strategies on the soil microbiome. Previous research has demonstrated the benefits and importance of these microorganisms for plant health. Multiple claims have been made that organic products promote microbial growth, whereas traditional products, such as pesticides and synthetic fertilizers, can negatively affect these microorganisms. With the development and release of new molecular tools, more scientific conclusions can be drawn. Understanding whether and how turf management affects the soil microbiome is crucial for turf managers to sustain high-quality turf and maintain a beneficial soil microbiome. To understand the influence of different management practices on soil microbiomes, a trial was designed to simulate a typical home lawn management plan with treatments using traditional synthetic fertilizers and pesticides and others using OMRI-approved organic products. This trial was conducted at Lake Wheeler Turfgrass Research and Education Center in two popular homeowner grasses, Zoysia grass Zoysia spp, Wild and tall fescue Shedinoris arundinaceus shrub. Turfgrass quality, soil physical and chemical properties, and the soil microbiome have been measured for each treatment over the last year and will be measured for the final time 2 years after the initial sampling. The soil microbiome was characterized by extracting DNA from soil samples and submitting it for 16S/ITS sequencing. Using the raw sequencing reads, CHIME-2 was used to identify the fungi and bacteria present in the trial. Soil samples were also collected from golf courses and athletic fields to determine how these management styles affect microbial communities. These samples include looking at creeping bentgrass, Agrostis stolonifera L., and Bermuda grass, Cynodendactylon L. pers, putting greens and athletic fields in North Carolina. The samples from these have been collected once and will be collected again 1 year after the initial sampling for comparison. Visual data from the trials, focusing on the differences between organic and conventional management strategies, have been analyzed. After 1 year of treatments, a significant difference in turfgrass quality was observed among treatments in the tall fescue trial under disease pressure. Turfgrass quality is rated on a scale of 1 to 9, with 1 being the lowest and 9 the highest. The highest turf quality was observed in the treatment that received both synthetic fertilizer and pesticides, which was significantly higher than the organic treatments, the synthetic fertilizer-only treatment, no fungicide applied, and the non-treated control. In the presence of disease, organic treatments, synthetic fertilizer-only treatments, and the non-treated control all resulted in decreased turf quality. Based on this preliminary data, organic treatments will begin to fail or have little effect on disease presence. In addition to turf quality, initial sequencing data from the tall fescue and zoysia grass trial have been analyzed. This data was collected before any treatments were applied. These preliminary results indicate that microbiome communities differ significantly between tall fescue and zoysia grass. These findings are expected given how different environmental factors can impact these communities. More sampling, analysis, and evaluation will help determine whether and how these management practices affect these communities. Golf course and athletic field samples are currently being analyzed to identify further how various cultural practices influence these microbial communities. Understanding how management practices influence soil microbiomes will encourage managers to promote a more diverse microbial community while maintaining a highly acceptable turf stand. You have been listening to the Turf Zone podcast. Follow the Turf Zone on X, Facebook, and LinkedIn for all things turfgrass, featuring podcasts, magazines, events, and more. Visit www.theturfzone.com for more.